Hi everyone, welcome back. In this particular video, we will be discussing the problem max repeat word. So let's just directly jump onto the problem. What we are given is a program which we have to write that takes what? That takes input of a list of words array. So list of word means list of strings will be given to us as inputs. And what we have to return is the most occurring word in the array, that is in the input. What is such word which is occurring most number of times, the highest frequency word or the most repeating word, anything. The important note is it is guaranteed that if there are multiple words with the same frequency, the program should return the lexicographically minimum string among them. Basically, if there is a tie, if two strings will have the same frequency, then the tiebreaker should be among those two strings or more than two strings. We have to take that particular string which is lexicographically minimum string, or you can say which is if only alphabets are there, which is alphabetically the minimum, which comes first in the dictionary order out of all of them. So we will try to understand the problem statement using some sample test cases. The first test case is there are four strings. Four is the number of elements in the array. The strings are hello world, cryo, cryo. So as you can easily see that in this particular string, hello is occurring for one times in this array. Then you can say world is also occurring for one time. If let's say there was no cryo, then among hello and world, what should be the answer? It should be the lexicographically minimum. So we can say H appears before W in the dictionary order, in lexicographical order. Hence, if there were only two such strings, hello was the answer. But since as you can see, there is also cryo present, which is occurring two times, it doesn't matter right now if cryo is lexicographically minimum or not, because it is having higher frequency. And if it is having higher frequency, there is no need of tiebreaker. So we can simply say cryo itself is the answer. So we just have to return the highest frequency string, that is cryo in this case. But let's take some test cases where there might be duplicate strings which are highest occurring. So let's say there is cryo, let's say there is maybe DSA, let's say there is LLD, let's say there is DSA again, let's say there is LLD again, let's say there is maybe, you can say cryo present, let's say there is DSA, and then last string which I am taking is nothing but the string maybe, as you can say, is cryo. Okay. So initially what we can say is, we will say that our answer would be anything. We don't know what is the answer. So we have to assume something as the answer and also the frequency of that answer. So what we can do is initially assume the answer as empty string. You can initialize it with anything. But the frequency of that, you need to maintain the frequency also. Then only you will be able to compare whether the current string is better than the answer or not. Is it more frequency occurring or not? More frequent occurring or not? So initially the answer we can say is occurring for zero number of times in the input string. It might occur in the string, but right now we can say since we have not started the traversal, we will say it is present zero number of times. In this array, we have taken eight size elements. That is eight elements are there, eight strings are there. The brute force approach, which I think should come to everyone's mind, is just check each word's frequency by running a loop and checking whether it is better than the answer. That is, first we will assume is cryo the answer, or maybe let's do what? Let's actually update this string as DSA only. Let's not say it is, or maybe let's say this is LLD, and let's say there is one more string so that the very first string is not the answer. Let me say there is one more string which is DSA. Okay, so let's start. Initially, what we have to check is cryo the highest frequency word? So for that, we have to run a loop over the entire array and check how many times cryo is present by comparing each word with the target word. So we will say target word will be given by the ith index, that is the outer loop variable, and the inner loop will be running on the entire string and checking how many times is cryo present in the entire string. So it is present for the first time because array of I and array of j are same, both are cryo. It is not present at first index. It is not present at second index. It is not present at third index, not at fourth, but it is present at fifth index. So cryo is right now present two times. Then it is not present at 6, 7, and 8 indices. So check, is it 2 more than 0? Yes, cryo should become the answer. So what we will do is we will make the answer become cryo and also the frequency of cryo become 2 because it was occurring two times that we counted using the inner loop. Now make the outer loop become DSA, that is the first index, and check how many times DSA is present. And for now, what you can do is you can just directly start from the first index itself. No need to start again from 0th index, because for every character or for every string, we can only check in the right hand side of it. Otherwise, if let's say DSA comes again, if you are checking again from left hand side, you might have already checked it when the I was 1. So no need to check when I is 6 starting from 0th index as J. Just start from the same index. So J will start from I only. It will say, is array of I equal to array of J? Yes. DSA present for the first time. It is not DSA. Is it DSA? Yes. Present for the second time. Not DSA, not DSA, not. Yes, DSA actually. We can say it is present for the third time. Then if you will continue, is it DSA? No. Is it DSA? Yes. So present for the fourth time. Is 4 better than 2? Yes, of course. So make the answer become DSA and make the frequency of DSA become 4 because it was present 4 times. 1, 2, 3, 4. Now, even if you have, let's say LLD, which you will say it is present how many times? Only 3 times present. So 3 is not better than 4. So don't update the answer. How about, let's say DSA was only present 3 times. In that case, you will say frequency of DSA is 3. How many times LLD is present? LLD is also present 3 times. Should I update the answer and make it LLD comma 3, or should I let the answer remain DSA comma 3? That scenario is nothing but the corner case or the tiebreaker situation. In that scenario, if two elements having same frequency, that is 3, 3 each for DSA and LLD, we have to take the lexicographically smaller string. So out of DSA and LLD, since D is smaller than L, you will say DSA is smaller than LLD. In order to check which string is lexicographically smaller or not, we can make an entirely different function where we will compare character by character. That we will discuss later on. But as you can see, since brute force is taking 2 loops, the overall time complexity will be the first loop running on the entire array of n length, second loop also running the loop on the entire array again. But to compare whether array of I is equals to array of j, we are checking that which string is same or which string is smaller, which string is greater. Or even for comparing lexicographically minimum string, again we are running the loop over characters of a string. So third loop, although it might be a function which you will be using, an inbuilt function, but still that function uses a loop internally. So outer loop over the array, inner loop over the array, and a function over the length of the string. So let's say L. So overall time complexity will be n into L. Now, provided that if you will go to the constraint, in the constraint it is mentioned that each array's length, array of I dot size means each array's length or each string's length, not array's length, but each string length present in the array will be maximum 10 size. That is maximum, there will be 10 characters. So given the constraints, you can ignore L because it will always be maximum 10. So n square into 10 is 10 square. You can say 10n square. And whenever we talk about the bigger notation, the time complexity in worst case, we never take constants. So simply, you can just simply say the time complexity is quadratic in nature. That is n square, where n is the array size. What will be the time complexity? It is n square. But how about space complexity? Actually, we will not require any extra space because we just require an answer variable that anyways we have to return, and a frequency variable which is of 4 bytes usually, an integer variable. So space complexity for this brute force solution will be constant in time or constant in nature. That is big O of 1. But can there be a better solution, better than the brute force? That is there a solution which might do the same thing in maybe linear time? The answer is yes. There is one more solution where you can do better than n square is you can just sort all the strings. That is actually a not the most optimized solution, but at least a better approach. So let's say approach number 2. Let's quickly write the array again. So there were strings like Crio present. There were strings like LLD, DSA. Let's say Crio again. Then let's say LLD was present again. Then DSA was present. Then let's say LLD was present. And let's say Crio is present. Let's take a different string this time, although we don't care what are the values. We only care about the approach and the tiebreaker condition. So in approach 2, what we are saying is, how about sorting this array of strings and sorting array based on lexicographical order? By default, in almost every language, if you will just sort a array of strings, it will sort according to lexicographical order only. That is nothing but dictionary order only. So if let's say your language does not provide a sorting on lexicographical order, you can omit this approach. You can directly have the next approach, which we will be discussing. But if it supports, then this is also a valid solution where what you can do is, after sorting all the array of strings, that array will become cryo, cryo, then third time cryo because there are three times cryo present. C is nothing but the smallest letter, or you can say smallest string in terms of lexicographical order. Then it will be two times DSA, DSA, and then it will be three times LLD. Now what you have to do is you just have to compare adjacents because all the adjacents will be duplicate. You can say all the duplicates which are occurring, they can never exist at any random index. They will always be at contiguous indices. It means whatever occurrences of cryo are, they will be one after the other. Whatever occurrences of DSA are, one after the other. Whatever occurrences of LLD are, they will be also one after the other. So now you can just run a loop and check how many times cryo is there. It is three times. Initially, again, you can assume your answer as empty string. You can assume your frequency of the answer. That is how many times it is occurring as 0. Cryo is occurring three times. So update the answer as cryo having frequency 3. Then DSI is occurring two times. 2 is not better than the current answer, which is 3. Don't update the answer. LLD is also occurring three times. But if two elements have same frequency, then we have to check for string lexicographical order. So cryo is smaller than LLD. So we have to take cryo. We have to take smaller string, not bigger. So lexicographically minimum means cryo itself will be the answer in this example. But the point is, how to do it even better? What will be the time complexity to first of all do the array sorting? Since array is of n size, in order to sort a array of n size, it will take n log n and then just a linear loop to count frequency of adjacents. It will be order of n. So n log n plus n. However, when you are doing sorting, the comparator, or you can say the comparisons which you are making between two strings to identify which string is lexicographically smaller, will again take you L times, where L is the string length. But given that L is constant, overall time in big O notation will be n log n only. Why? Because n log n is better than n. We always take the biggest term in power of n. So at least it is better than the previous solution. However, if you talk about the space complexity, if you are applying arrays sorting using, let's say, quick sort, or using maybe a sorting which does not take extra space, it will be constant. However, if you apply, let's say, merge sort, it might take linear also. So it depends on the sorting technique which you are using. Is it using any extra space or not? But provided that this is not the most optimal solution, then what is that? So the answer is, how about storing the frequencies of each string in another data structure? Not just sort the input array, not just run in multiple loops on input array, that is nested loops. How about storing the information which we need? What is the information which we need? We need how many times cryo is present? Cryo is present three times. How many times DSI is present? DSI is present two times. Storing how many times LLD is present? LLD also is present three times. How about storing this information? So what is this kind of information known as? This is the key value pair data structure, or the key value pairs which we have to store. The key being the string for which we have to find the frequency, and the value being the frequency of that string. That is how many times the string is occurring in the array. So key being of string type, value being of integer type, what should be the data structure to store key value pairs? That data structure is known as a hash set. Actually, not a hash set, but a hash map, or you can simply say a map. So a hash map will insert all the key value pairs in constant time. If strings are of constant length, that is only of 10 length, in general, it will take order of L time to insert a key value pair where key is a string. This is average case time complexity. Whenever we talk about hash maps, we always talk about average case. This is single insertion per insertion. Similarly, for single search operation, it will be order of L. For single remove operation, it will be order of L. However, we don't have to do remove operation. We only have to insert or search. Provided that L is only 10 in the example, we can say it is constant time average case insertion or searching. So what we will do is we will initialize the hash map with an empty data structure, or you can say there will be zero key value pairs present in the hash map. We will do a traversal over the input array of strings and store them in the hash map. Along with storing in the hash map, we will also try to maintain the answer. So let me just make it a little bit for the side and let's start. Initially, what we can say is the answer is empty. Initially, what we can say is the frequency of the answer is zero, zero occurrence of the empty string in the input array. Now let's start a traversal. How many times cryo is present till now in the hash map? You can say in hash map cryo is not present. So what should we take the older frequency of cryo is? We should take the older frequency as 0. What should be the new frequency of cryo? Since it is occurring for the first time, we will put the new frequency as 0 plus 1. That is increment the older frequency by 1. Similarly, you will do it for LLD because LLD is occurring for the first time. You will make the frequency become 1. But before going to LLD, you will also update the answer and make it cryo having the frequency 1. Now you will say LLD, how many times it is present? 0 times. What will be the new frequency? 0 plus 1, which is 1. But should I make the answer become LLD? The answer is no. Why? Because the highest frequency string is of frequency 1. The current string is also of frequency 1. Out of cryo and LLD, both of our same frequency, we should do a tiebreaker based on lexicographically minimum. So we should let the answer remain cryo only, not LLD. Go to DSA. So DSA will also be put as 0 plus 1 as one frequency only. But since again cryo versus DSA, cryo is of smaller lexicographical order, tiebreaker will let the cryo remain the answer. And for that matter, let's do what? Let's make the problem statement interesting by inserting DSA in the last. Then cryo again. Now it is obviously occurring for the second time. So it will just increment the highest frequency. Now cryo will be the highest frequency string with two occurrences, two frequency. Then LLD will also become two frequency, but cryo and LLD have same frequency, take lexicographically minimum, which is cryo only. Similarly for DSA, it will become two frequency, but right now you will say the two frequency is same for cryo, take the lexicographically minimum. But as soon as the LLD occurs for the third time, now you don't have to check for lexicographically minimum string, because now lexicographically minimum will only come in a tiebreaker situation. Now it is not a tiebreaker. LLD is occurring 3 times, cryo was occurring 2 times. So make the answer become LLD with the frequency 3. Finally, if you will go to the string which is DSA, you will say DSA will also become 3 frequency. Should update the answer. The current answer is of 3 frequency. The current string is of 3 frequency. So take the tiebreaker situation, LLD versus DSA, which is lexicographically minimum. LLD is greater, DSA is smaller. D is smaller than L. So update the answer as DSA with the same frequency 3 only. So finally, you just have to return the string, not the frequency of it. So what will be the time complexity to do n insertions, n searching, given that single insertion, single searching is constant? N insertions, n searching will be order of n. But are we taking any extra space? The answer is yes. We are creating this hash map of n key value pairs in worst case. Every key can be distinct, every key can be unique. Basically, why we are saying that in this current hash map there are only 3 strings? Because hash map only maintain unique keys. But if all the strings are different in the input, the number of key value pairs in the hash map will be equivalent to array's length. So in worst case, the space can go n only, although right now it will be only having number of unique strings, which is 3 in this case. So is it better than the previous approach? Yes, of course. The previous approach, approach 2, sorting based, was taking n log n time and n space. But right now, the current solution is taking n time, n space. So time is still optimized. However, if let's say you say that space can also be constant in the previous scenario, then you are taking some extra space, but still time is preferred over space complexities usually. Whenever we say there is a trade-off, usually we should go for a better time than a better space. So what we will do now is we will try to write the code, not the code, but actually the instruction manual for this problem. But before writing the instruction manual, one more thing which we have to discuss is how to compare two strings based on lexicographical order. There must be some inbuilt function present. If there is, no need to create a function by your own. Just limit to the current problem statement. That is, just limit yourself to the map implementation, not implementation, but again, map usage. We will be using the inbuilt map, which your language provides. But how to check two strings, which is lexicographically smaller, if let's say that function is not available? So what I will do is I will take two strings. First string, what I'm going to say is A, B, C, or maybe A, B, D, then E, F. The second string I am saying is A, B, D, X, Y. And we have to compare which string is lexicographically smaller. So a string is lexicographically smaller than the other string if the very first non-matching character of that string is smaller than the other string. That is, we will have to find, first of all, what is the first non-matching character from left hand side. Is A and A non-matching in both the strings? This is, let's say, S1, this is, let's say, S2. No, A and A are same. Is B different from B? No, this is also same. Is D different from D? No, this is also same. As soon as we go to E versus X, yes, now the characters are different. And as soon as you go to a first non-matching character, then what you have to do is you have to compare which one is smaller. So since E is smaller than X, it means A, B, C, D, E, F string is smaller than A, B, C, D, X, Y overall in lexicographical order. So in order to find which string is lexicographically minimum, you have to run a loop over both the strings simultaneously till the point that you find a non-matching character. However, there is one more corner case here. How about one string is, let's say, Crio, another string is, let's say, Crio dot do. In that scenario, if one string is a part of another string, this string is actually a prefix of this one, then which string will be smaller? You will say, compare character by character. C is equal to C. Right now, both are equivalent. R is equal to R. I is equal to I. Till now, we have not found the non-matching character. O is equal to A. But now, if you will go to the fifth character or you the fourth index, you can say, then there is no character present here, but there is a character present here, no matter what is that character. So since this string is a part of the other string, or this string is a prefix of another string, still the first string will be considered smaller than the other one. So this is a corner scenario when comparing which string is lexicographically minimum. So now that we know all the components to solve this problem, let's write the instruction manual. So first thing what we have to do is, let's say that we have to maintain a hash map, create a hash map. Hash map is nothing but a key value pair data structure of keys as strings, and values as integers, because values is nothing but frequencies of how many times those strings are occurring. Initially, it will be empty. What we will do is we will maintain a answer as what? As empty string, and the frequency of that empty string as 0. Because initially you have to assume frequency to be negative or 0 only. You can't assume anything to be positive. So now that we know, or we have created an empty hash map, we can run a loop, and probably a for each loop over each string in input array. That is, we will directly run the loop over strings. We don't need the indices of those strings. Where are those strings present? We don't need these indices 0, 1, 2, and so on. We are directly running the loop over the strings itself, a for each loop. So what do we have to do with that string? First check what is the old frequency of that string from the hash map. So get the old frequency of string from hash map, but the notice, if that string is not present, if string is not present in hash map, what you have to do is take default value as how much? If the string is not present, default value should be taken as 0. Take default as 0. Whatever the old frequency is, add 1 in it and put it back. That is, add back the same key value pair. That is, let's say first the key value pair was Crio comma 0. Put it back as Crio comma 1. Then if it was Crio comma 1, if it is occurring for second time, put it back as Crio comma 2. With the same key, update the frequency by incrementing it. So put the frequency, put the pair as the string comma the old frequency plus 1 in hash map. That is, you can simply say that you are incrementing the frequency by 1 for that character in hash map. But also we have to check whether this string is becoming the answer or not. So if the frequency of current string, if the old frequency plus 1, or maybe what we can do is directly maintain the new frequency. What will be the new frequency? Old frequency plus 1. So if old frequency plus 1 is what? If it is better than what? It is better than the current answer, current frequency. Let's say this is maximum frequency. If the old frequency plus 1 is better than or more than maximum frequency, then it is of course the answer. No need to compare for lexicographical order. So update answer as the current string and maximum frequency as old frequency plus 1. But if the current frequency of the current string is equal to the maximum frequency, still there might be a chance that we are updating the answer. If old frequency plus 1, we are writing else if condition. Either old frequency plus 1, that is the current string frequency, will be more than maximum, or it will be equal to maximum. It can be both. That's why else condition is what we have provided. If the current frequency is equal to the maximum, then check or update the answer with lexicographically minimum string. Update answer string as lexicographically minimum string of what? Of the current answer and the current string and current string lexicographically of them. And for that, we will be creating a function. After we are done with the loop, what we have to do is we have to just return the answer string. That's it. But just quickly, let's maintain a function which will give me the lexicographically minimum string out of 2. So it will return a string, and let's say the function name is lexicographically min. It will take 2 strings as input and it will give the minimum out of those. So in order to find minimum, we have to run a loop over both the strings, but only to the minimum of lengths. Because let's say in the second example, what we discussed, if the first string is of 4 length, the second string is, let's say, of 7 length, then what you have to do is you have to only run the loop till 4, that is till less than n1. This is n2. However, if both strings are of same length, then we can run the loop till that length itself. So find the minimum length by doing what? Taking the minimum of, we will say, find n as minimum length of both strings. And once we have find it the minimum, now we will run a loop, a index based loop, run a for loop over indices 0 till n minus 1, whatever n we have figured out, and check is the current character non-matching, because we have to find the first non-matching character. If current character at index in strings a b are non-matching, is a non-matching, then check which character is smaller. If the first string is smaller, if character in A is smaller than character in B string, then return the first string, return A. Otherwise, we have to return B. But this only have to do when both strings have non-matching character. But how about if every character is matching and you can say the first string is a part of second string or second string is a part of first string? That is, after the loop, we have to just return the smaller length string. So if length of A is smaller than length of B, then return A, otherwise return B. We will be discussing the code for the problem maximum repeating word. So I will be picking Java as a medium to write it. So in order to do it in Java, how to create a hash map in Java? That is by writing hash map, angular brackets, the key and the value, two data types. Key will be of string data type, value will be of integer data type. Why? For every string, we have to find the frequency. And we can say the hash map name is HM. You can name it anything, but I am writing HM. H stands for hash, M stands for map. And this is how you create an empty hash map initially. On the left hand side, if you want, you can just write it as map also. That will also work. So initialize the answer with what? Initialize the answer with an empty string. However, answer string initially can be anything, but the important part is the frequency of that initial answer should be 0. The maximum frequency should be 0. Now you have to start your logic of comparisons, that is run a iterator based loop, or you can say a for each loop over the input string, input array. So I will run a loop over each string of the input array and check whether that string is already present in the hash map or not. If that string is not present in the hash map, take the old frequency as 0, otherwise take it as whatever the frequency is. So in order to do it, there is an inbuilt function in Java to get the frequency of a given string or value of a given key if key is present. The function name is get. But if we want to provide a default value instead of getting null, if the key is not present and if you're using get operation, it will give you null as a value if the key is not there. But to get 0 as a value instead of null, you have to use the function get or default. So what I will do is I will take the old frequency as what? As the hash map get or default. The first parameter will be the key for which you want to get the frequency, get the value, that is string. But if the key is not present, then second parameter should be the default value. That is, if key is not present, it is occurring for 0 times in the string till now. But now we have to put the new frequency. Put is to basically add a new key value pair or update a key value pair by the same string with the old frequency plus 1 value. But also we have to check whether it is the new answer or not. So in order to check it, we will check is this current frequency, that is old frequency plus 1. You can store it in a new variable, new frequency, and compare with that directly. But I'm just using the same thing. Is it more than the maximum frequency? If it is more than the maximum frequency, then no need to compare for lexicographical order. Just simply say that the answer string will become the current string and the answer frequency, that is the maximum frequency, will become the current frequency, that is old plus 1, the new frequency. But we also have to update the answer in one more scenario where the tie is there. That is, the current frequency of the string is the same as the maximum frequency also. So in that, we only have to update the answer if the current string is lexicographically smaller. Or you can say we have to update the answer with the smaller of both. So for that, we have already created a function lexicographically minimum out of two strings. First string will be the str, the current string, and second string will be the answer. Whatever minimum will we get based on dictionary order, we will update with the answer. No need to update frequency because frequency is anyways is the same. Even if you update it, it will remain same. And finally, you have to return the answer. Only thing remaining is how to do this lexicographically minimum operation. But you can take a screenshot of this particular code. I hope everything is working fine in this. Let's do what? Let's now write the code for lexicographically minimum. So for that, we have to first find the minimum length out of 2. And in order to do it, what you can do is use a min function, math.min function, where you will pass both the strings length, a.length as well as b.length. After doing that, you will have to run a loop over the both the strings together. That is, run a single loop by indices going from 0 till less than n and check what is the first non-matching character. So in order to check the first non-matching character, you will say if the character, let me store the characters in two variables. If the character at A is nothing but A dot char at the index, and the character at B will be the B dot char at index. Now we have to check which character is smaller, but only check it if the characters are not equal. If they are equal, then you can continue. You can just skip. If characters are not equal, then we have to check which character is smaller. If the first character is smaller than the second character, the first string is lexicographically smaller. So return A. Otherwise, return B. But this is only when the non-matching character was found. What if the non-matching character is not found at all? That is, one string is a prefix of another string. In such a scenario, what we have to do is check the length of the strings. If the first string's length, that is a dot length, is smaller than b dot length, it means a is a prefix of b. So return a. That is, Crio is a prefix of Crio dot do. Crio is lexicographically smaller. Otherwise, B is lexicographically smaller if B's length is shorter. So now that we are done with the entire code, let's run this code and see if it is going to work fine or not for the sample test case. And if it will work fine, since we have already discussed all the corner scenarios in the approach video itself, we will not repeat them. However, there is a spelling mistake in the line where we have used length, and the spelling mistake is in the length function. Let's run it again. Hopefully it should work now. It is going to take some time to run, but let's submit it and confirm if it will work for all the corner scenarios or not. If it will, then you might try to solve the problem where you are not just expected to find the maximum frequency word, but also the second maximum frequency word, or also sort all the strings based on their frequency. That is nothing but frequency sort. So this solution is working fine. In how much time complexity? It is linear time complexity, where we are considering strings length to be constant. So order of n is the time and order of n is also the space. Why? Because we are creating a hash map of pairs and there can be n such pairs where n is the input array's length. So linear time, linear space solution. We will meet in a new video with a new problem. We are done with this one. Till then, bye bye. Take care.